Let me show you how to create a menu. So I have this example. I've coded a bit of here. This is part of the menu I have in my project. So it is based on the MCUFRIEND library, which is based on the Adafruit. But MCUFRIEND library has all the serial communication that happens at the beginning of the connection between the driver of the LCD screen and between the Arduino. So it's like kind of a driver library for the touchscreen monitors, small touchscreen monitors like Adafruit 320 pixels or 280 pixels, 240, 380, and so on. And those are pretty nice. They have pretty nice feel, those touchscreens, so that's why I chose one. They're around 15 quid, around. It may be 12, it may be 22, but you know, depending on the size of the screen and some shipment. First, you need to download the MCUFRIEND library. So we are getting it from the GitHub, and you need to extract it into Arduino libraries, and here I have the MCUFRIEND KBV master, and just restart the Arduino and it should be in the examples. And in the examples you need to find MCUFRIEND, and first thing you run is the touchscreen calibration native. So you connect the Arduino. You compile this thing and you upload it to the Arduino. Remember to turn on the serial monitor, because it will spit out us some values that you will need in your project. So if it doesn't work because there is a file in the MCUFRIEND library that defines support for different screens or drivers or whatever it is. It's this file. It is located straight in the MCU library folder, the CPP file, and it defines support for different screens. So let's just run an example, the most basic example. And as you can see in the setup, you see this is very simple example. In the setup there is the identifier variable, and it reads ID from this identifier, and then it prints it out on the screen, right? Or no, on the serial. So when it prints out on the serial, you just need to find this this number somewhere in here. So when you find this number somewhere here, just search for this number in the library, and based on this there is one of those defines here that may be just commented. The reason why they are commented is because this library writes the support for different screens, for different monitors to the Arduino, and it compiles the support for many screens and sends it to the Arduino. So it includes more support that you actually need during the operation of the screen, but it's in the cost of the memory, right? So as it could work on the Arduino Mega straight away with all the defines probably on, it wouldn't work on the Arduino Uno with all the defines on. So you just need to try all of them. Okay, so with this example, you compile it, upload it, And here is what you will get. This is the calibration screen. And just follow the instructions. So it spitted out here some text, which is basically copy paste, but the same text is also in the serial monitor. And this text is calibration for our touch screen, because it's resistive touch screen. When actually I'm pressing the buttons, it reads the numbers. It reads the voltages from this resistive touch screen, and this way it is calibrated. You see here are those numbers: left, right, top, bottom, and the width and height of the screen. Of course, there can be two calibrations, portrait and the landscape calibration. Okay, so let's get to the menu I prepared a bit. And this is the one. So first there is the include of the Adafruit. Wait, maybe first I show the menu a bit. So this is part of the menu for the XY axis, and it has simple two buttons, two numbers displayed and refreshed with every refresh of the main loop, and two numbers displayed earlier. So here's how it is written. So first there is the include for the Adafruit GFX library, because the MCUFRIEND library uses the graphics options from the Adafruit. So it's obviously reasonable. And moreover, Adafruits have some ads I will talk about later. Then there's the touchscreen library, there is the fonts library. Those are the pressures for the touchscreen. I think they are somewhere in the calibration, probably. This is the minimum and maximum pressure that you apply to the touchscreen to have the cursor on hold or pressed. And here are those numbers from the calibration. And this is the creating of the new touchscreen object. And here we have the function that is responsible for telling us the position of the cursor and if it was pressed or not. Here is the pressed function. .getXY. You can just refresh it with every your main loop and tell in what condition is the cursor, right? So cursor X and cursor Y will be the cursor positions, and the pressed will tell you if it was pressed or not, true or false, right? So there are some defines of the basic colors. It is displayed this way, that first I draw X, Y, I draw the this button, the next button, and with every next display of this part of the menu, I just refresh those two zeros, and I also refresh if those buttons were pressed or not. And I may change the display of just one of those buttons, right? And the same thing happens with every other menu. So in this menu also, I first draw it once overally, and then I just refresh if something was pressed or not. And the same with this menu, I also just once display all of this and then just refresh those two buttons if they were pressed or not. So those displays are being displayed by those draw main menu function, refresh main menu function. This is this menu, by the way. And also I have the draw 0 position menu. It is this menu. Refresh 0 position menu. Draw control jog menu and refresh control jog menu. So this is this menu. So first I draw this menu, right? So TFT is our object that we created here at the beginning as the one from the MCUFRIEND class, from the MCUFRIEND library. This is the class in there. So we are just creating this screen object. So we have this TFT fill screen black, which obviously just washes our screen to black, every one pixel of it. And then we just set text color, we set text size, set cursor 2015, which will be around here. And we print this message, set current position to 000. And we also print those two buttons. Notice that buttons doesn't have defined place or place on the screen in here. Neither they do not have defined the text size. Overall, everything that defines these buttons, right? Their sizes, also their colors, and so on. And those things are defined in here in the setup. They are declared in here earlier, those buttons. And notice that they are I actually have sorted them according to the menu they belong to. So in case of the set 0 position menu, those are those buttons in here. Those two buttons in here. Yes, no. So those yes and no buttons are then defined in the setup. And they are defined like this. And this is our object of the screen. There's this init button function. It's not a constructor, right? Notice also that they can be earlier declared. So this is the X, this is the Y, which is obviously somewhere in here. Then there is the which and the high, how wide it is and how high. And then there are a few colors defined. And the text in this button. This is highly constrained, the length of the text in this button. It shouldn't be too long. The last thing is the size of the text. Okay, so if we have the button declared, then it is just being displayed by writing this function. It is being drawn, right, by writing this function. And notice that there are two ways of displaying this, as true and as false, which is in the refresh, right? And this display that you see in here is the true one. And when I press it, it will be displayed by a short period of time as the false. Ta-dam. So it was just the alternative way of displaying this. When I press it, it will be displayed as the false. Just for a short period, right? You can see it on the every button. And this happens because with every next refresh of the menu, I just check if the button was pressed. You remember this earlier press function? So I can check basically if the button was pressed, because I refreshed this cursor earlier with every run of the main loop, right? Here it is. And then if I find out that the cursor was pressed in this position where this button was, I can just do something. And in this case, I draw the button false, right? So it just changes its colors in reverse. And I also change the menu. Basically, when you press yes, the menu should change back to the primary menu, right? Because it's just confirmation screen for this option. Also on the no, right? But here in the yes, I just do whatever is needed by this button, by this menu that I wanted to do. And I change menu back to the menu 1. This change menu thing has one variable that it relies on. It is called current menu. So in the main loop, notice that I'm just calling only this refresh menu function. And during the change menu function, that after some change in the menu, like it was in the refresh position 0 function, this changes the one variable that is responsible for displaying the current, for remembering which current menu I am displaying. And it always goes with the draw one of the menus as the first time when I'm just switching to the new menu. And with every next main loop, I won't be calling this change menu function. I will be calling this function, right? So this is in every main loop. And notice that each one of those draw menu functions basically starts the same. Here is draw main menu. First, it just turns all the screen black, then it displays whatever is on the screen, right? For the first time, whatever is constant on the screen. So this is constant, x, y. So x is constant, y is constant here. Those two buttons are constant until they are pressed. But the good thing about that being pressed is that if you want to change their color scheme, you just throw over those currently existing buttons, right? So there is no need to redraw the entire menu when you are just pressing one button. That will change the entire menu anyway, all over. And then after just printing those constant things in the menu, then I just use the refresh function, which prints the things that change in the menu. So in the refresh main menu function, those will be those two numbers. And how they are printed, there are a few ways of printing it. One way is to, at the beginning of the refresh main menu function, fill this part of the screen in black. So yeah, maybe I demonstrate. To understand it better, maybe I just change color. So now notice that this part of the screen with every one display is just being drawn blue over whatever was before in there, and then there are printed those two zeros. Those are the numbers that I print actually. And before I obviously set the place on the screen to print them and the color of this text. And another way to do it is to quantize actually exact pixels which were drawn the last time the number was displayed, and print them black, right? So yeah, actually I leave this one. And what happens here is that I am printing the same number that was displayed just the frame before, and I am printing it in the color of the background. So as I am printing this in the color of the background, the number stays in the color of the background and is not. And I can print the and I can print the new number over it. Actually, this version it seems slower. So maybe I go back to the filling the rectangle. Yeah, we'll think about it later, but what else? I also have those two buttons that can change those menus to different ones, right? There's the 0 position button and the control jog button. You change menu to 2 and the 4. So this is the change menu, it changes the current variable of the menu to 2 and to 4. And with every next refresh, it will be different menu displayed. So how to start this screen is basically you write it in here and then you define all the buttons and you quantize those buttons to the appropriate menu screens, to the appropriate menu functions, right? And that's the overall trick with it, but you can go further. Actually, in the MCUFRIEND library or in the Adafruit, there's the example where you can input the number to the Arduino. I'm not sure if I have just too old IDE or I don't have just simply this example, don't know why. But there obviously are ways to do it. Okay, so let me show you how this works in this project in the units menu. So we can forget, fortunately, about this negative number function, about this part with the negative number. Here is the number, right? And it is just some global variable. And this number is just being sent through this function here. So I'm clicking it and it's being sent. And here I'm getting the number, I'm displaying all those buttons, okay, and return menu. So here are all those buttons and the number is being displayed. and here then the buttons, right? So what do we have in the refresh input menu? So this is pointer to the function which returns void. Then there is the pointer to the function, and this is the function of 1 int32t. And it also holds them. I won't get in deep into this, but as I started it from this menu, it should also hold this number where to finish after I click OK or return, right? Where to change the menu back. Because this function that it gets in here is the function that sets the variable that needs to be set based on earlier getting the variable from the drawInt32 input function, which was called earlier its global variable, right? This global variable is this one. No, it's this one. This one is the global variable that I'm setting every time I'm calling this, and after this is called, this is being called, right? The refresh function. And so we have something to work on at the beginning. And then all those buttons, what they do is when they are pressed, they do arithmetic math on this number in just simple times 10, for example, plus 1 arithmetics. This is the safety condition in case we overflow this number, right? So it will be higher than int32 actually can take. So all those 1, 2, 3, 4, 5, and so on buttons do arithmetics on this. And then when I press OK or return just changes the menu back. And the OK button uses this function, pointer from this variable that this arithmetic math was done at, and is maintained just only by those refresh int32 input function and the draw int32 input function. So this pointer because this is the pointer sent to this function, and this pointer is sent to this function in the refresh x pulses menu. So here it sends this pointer to the function. This is the global function. Here it is, set pulses x. This is the function that connects the menu with the stepper classes. So it actually changes the stepper motor class pulses per centimeter variable, and also writes to EPROM and so on. But yeah, that's overall how you connect the menu. So let's go back to the menu example, and I will show you one more example. Okay, so this is the jog menu. Notice that when I press it, it refreshes the entire menu, and it draws this button as the false. With the draw function of this menu, I obviously fill the screen black, and then I draw those buttons depending on which option was selected, right? This is the global variable that stores this option. So for every of these buttons, I'm doing the same. And then with the refresh, I can just change this this jog setup variable. Actually, it is changed by set jog2, so there is another function here but this function actually only does, well, only what it does, it only changes this one variable. And in the refresh, there's obviously also the again call to again draw the jog menu, right? Because the jog setup number has changed, so one of those buttons also should change. The entire menu just being redrawn, just for the purpose of getting back this old color of the button